Hey guys, today we're going to talk about probability. Now probability can be defined as how likely an event will happen. Okay? There are two types of probability we are going to talk about today, mainly theoretical probability, which is what should happen given the information available. And then there's the experimental probability, which is what actually occurs when an experiment is conducted. We also call that the relative frequency. So you will see experimental probability and relative frequency used interchangeably. First, let's look at what we're going to call the likelihood of an event occurring. Now, we've talked a little bit about this in class, and we've talked about events that are impossible, events that are unlikely, events that are equally likely, events that are likely, and events that are certain, that are definitely going to happen. And we can assign a number from 0 to 1 with those categories. So something that is impossible would be a 0, have a 0% chance of happening. Something that is unlikely, something that could happen but probably wouldn't, would be given a 1/4 or 25%. Something that is equally likely to happen as not happen would be 1/2 or 50%. And something that is most likely going to occur, most likely going to happen, would be given a 3/4 or 75%. And then something that is absolutely, definitely going to happen would be given a 1 or a 100%. So just a couple of examples of events that are impossible, unlikely, equally likely, or certain. Things that are impossible would be like cows flying or going back in time. Now, those events might possibly happen in the future, but right now they are not going to happen. So cows flying, not going to happen. And going back in time, again, not going to happen right now. If we look at unlikely, okay, finding money on the ground. We're walking around, we find some money in the ground. That doesn't happen very often, okay? Or winning the lottery. Winning the lottery, again, doesn't happen. That's kind of what the people who run the lottery rely upon, is that people are going to keep playing, thinking they're going to win, but in reality, you don't usually win too often. Something that is equally likely, like flipping a head on a coin. Okay, the coin has two sides, a head or a tail. You have a 50-50 shot at getting head or a tail. And then same thing with drawing a red card from a standard deck of cards. Okay, we're going to talk about the makeup of a deck of cards in just a second, but there are two colors for a standard deck of cards, red and black, and there's an equal number of red cards as there are black cards. So you have a 50-50 shot of drawing a red card from a standard deck of cards. If we look at things that are likely, you will most likely drive in some kind of automobile this week. Okay, you might not. There's a possibility that you might not, but most likely you will be in some kind of car, whether it's a bus or a car or something this week. And then it is likely you will talk to a friend of yours today. You might not. You might be homesick, or something like that might have happened. You might be out of town, but most likely, if you're at school, you're going to be talking to a friend. And then things that are certain. We are definitely going to be paying taxes at some point, whether it's on food or property taxes or clothing or something else. You will most likely pay taxes during your life. And then breathing. Breathing is another thing. If you're watching this, you're breathing. Okay, because we need to breathe. All right, so when we talk about theoretical probability, what should happen, some common things that we need to look at are dice results and the makeup of a deck of cards. Now, the charts I have here, we have, the first one is when you roll two standard six-sided dice, okay? When you roll the two six-sided dice, you could get two different results on each of those dice. Understand that each die is a different result. Even, for example, as we have here, so like if I roll my first die, I could get a 3, and then if I roll my second die, I could get a 1. That is a different result as rolling a 1 on my first die and a 3 on my second die. I would really like for you guys to have this written down if you don't know the dice chart and if you don't know the makeup of a deck of cards. These are commonly referred to things that we will come across quite a bit during this unit, and it's just expected that you know what these the makeup of these items are. So it's not like you have to study them, you just have to have a basic understanding of them, but please make sure you get that down. More importantly, because I think we can kind of figure out the dice chart just because we know that the results possible are 1 through 6 on both dice. But the deck of cards is something that we need to talk about. There are 52 cards in a standard deck. There are 2 colors. There's a red color and a black color. Each, there are 4 suits, and there are clubs, diamonds, hearts, and spades. Okay, clubs are sometimes called the puppy's paws, and those are the spades. And there are 3 face cards. There is a king, a queen, and a jack. There is also an ace for each color, and then the numbers 2 through 10. I should have a 10 down there for each color. So we need to understand that there is a makeup for our deck of cards here, and like I said, we're going to be referring to the deck of cards, and we're going to be practicing this in class. So let's just look at some basic probabilities of dice rolling first. So we look at this and we say, what is the probability of rolling a sum of 7? Okay, well, if you look back at the dice chart, there are 6 opportunities of the total of 36, and that would reduce down to 1/6. So there's a 1 in 6 chance of rolling a 7. And basically what this means with this theoretical probability is if I roll the dice 6 times, I should come up with 1 time of rolling a sum of 7. So how about the sum of 10? Well, that would be 3 of 36 or 1/12. So if I roll the dice 12 times together, 1 time should come up a sum of 10. At least 1 6 on either die. Again, so there's 11 of 36 on that, or, well, that's a simplified fraction. A sum less than 5. Okay, so there are 6 opportunities of that occurring out of the 36, again, or of 1/6. An even sum, there's 18 of 36 or 1/2. And then we have an odd sum, and this is 18 of 36 again, or 1/2. Now remember, these are all theoretical probability. If we look at the probability of drawing cards, okay, again, this is all theoretical probability. This is what should happen. If we wanted to draw a black card, it would be 26 of 52 or 1/2. Remember, there's the 2 colors, red and black, and there are 52 cards in the deck. How about a club? It would be 13 of 52 because there are 13 cards in each suit, and that would be 1/4. A face card, a king, a queen, or a jack, There are 4 suits and 3 face cards for each suit, which would be 12 of 52 or 3 out of 13. A number card. There are 9 number cards. Okay, there's 2, 3, 4, 5, 6, 7, 8, 9, and 10. So and there are 4 suits, so that would be 36 of 52 or 9/13. A black 8. So there are 2 colors. There's the red and the black. There are 2 black suits, the spades and the clubs. So that would be an 8 of clubs and the 8 of spades. So that would be 2 of the 52 or 1 of the 26th. If we look down here, we have an ace. There are 4 aces, so 4 of 52 or 1/13. And then as a final example, we have the ace of spades. There's only 1 ace of spades. So that would be 1 of 52. So again, these are just the theoretical probabilities. If we want to talk about experimental, well, that could be anything. And we're going to be practicing with the experimental probability in class, and I will see you there. Us.